The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Question number 12 basically wants us to capitalize upon dimensional analysis. So it says, cheetahs have been recorded to run at speeds of nearly 125 miles per hour. How fast is this in meters per second? So basically we just want to go from miles per hour to meters per second. Your professor gives you some handy tips at the very top of your page, and he says 1 inch equals 2.54 centimeters. 12 inches equals 1 foot, and 1 mile equals 5,280 feet. So basically, we're going to be doing a lot of multiplying to cross out different units. So let's go ahead and start out with the miles per hour, and we'll go from hours into seconds. So the way we're going to start this is we're going to say 125 miles for every hour. In every hour, there's 60 minutes. In every minute, there's 60 seconds. So, this is how we end up crossing out the hours. Hours cross with hours, minutes cross with minutes. We're left here, right now, in units of miles per second. So, the way your professor wants us to do this is he wants us to convert from miles to feet, feet to inches, and inches to centimeters, and centimeters to meters. So let's go ahead and cancel out the miles with the feet. So we know that 1 mile is equal to 5,280 feet. Now notice every single time that we do a dimensional analysis problem, the numerator and the denominator have to cross. So the miles on the bottom cross out the miles on the top. Now we're left in feet per second. Now we want to go from feet to inches. It tells us that 1 foot equals 12 inches. So we're going to multiply by 12 inches for every 1 foot. Here again, feet are going to cross out with feet. Once we see everything's crossed out, we're left in terms of inches per second. He also tells us that 1 inch is equal to 2.54 centimeters. So we're going to multiply by 2.54 centimeters for every 1 inch. Again, inches cross out with inches, and we're left in terms of centimeters per second. The last thing you should memorize is how many centimeters are in a meter. Well, there's a really helpful mnemonic device that if you're going to take additional science classes, I like to remember, and it's Greg, my killer hamster, doesn't like dunking cookies, milk, M&Ms, no peanuts. And what this stands for is giga, mega, kilo, hecta, deca. The L is basically the base unit. It could be liters, meters, whatever you want to use. Deci, centi, milli, micro, nano, and pico. So if this is 1, count up to 3. 10 to the 1, 10 to the 2, 10 to the 3, 10 to the minus 1, 10 to the minus 2, 10 to the minus 3. Every time you get to 3, then it skips 3. So from 10 to the 3 to 10 to the 6 to 10 to the 9, 10 times 10 to the minus 6, 10 to the minus 9, and 10 to the minus 12. So here, we're going from centimeters to meters. So there's 10 to the minus 2, or 100 centimeters in 1 meter. So now we want to cross the centimeters out with the meters. So 1 meter has 100 centimeters. Centimeters cross out, and we're left in terms of meters per second. So if we plug all of this in our calculator, 125 divided by 60 times 5,280 times 12 times 2.54 divided by 100, we get 55.88 meters per second. And if we check on our test, the correct answer is 55.9 meters per second. So they round it up. And a constant for you to memorize is 1 mile per hour equals 0.44704 meters per second. So 1 mile per hour equals 0.44704 meters per second. So if we would have done 125 times 0.44704, that should give us 55.88. Let's check if that's correct. That is correct. So this would be the constant to change from miles per hour to meters per second. However, your professor wants you to do it by dimensional analysis and using all of these numbers to cross out. They're really testing you here, and maybe next time he'll ask you to go to kilometers per hour, so you can't just use the conversion factor.